Alright, so today we're gonna take a look at sets, okay? And this is the definition for sets. It's a collection of objects specified in such a way that we can tell whether or not any given object is or is not in the collection. So we call them elements of the sets. The objects in the set, we call them elements. It could be finite or infinite. So infinite means that the set doesn't have a limit. Infinite, it goes on forever. Finite means that it's got a limited number of elements. Okay. Equal sets are going to have exactly the same elements. So 1, 2, 3, 3, 1, 2. This is an example here. Equivalent sets have the same number of elements. So these two are different elements, but we have the same number of elements. 1, 2, 3, 1, 2, 3. So they are equivalent. Example 1, it says W is the set of days of the week starting with T or S. List the elements of W. So let's see. So we have W equals to T or S, right? T or S. So Monday, no. Tuesday, yes. Tuesday, Wednesday, no. Thursday, yes. Friday, no. Saturday and Sunday, right? And that's it. That's our set W. All right. All right. Example 2. P is the set of multiples of 4. List the elements of P. So let's see. So we have P equals multiples of 4. So this is going to be an infinite set, right? Because we can get an infinite number of multiples of 4, right? And the list, this is 20. Let me erase this. Erase, how do you erase this? Erase. Come on. 20, 24, and so on, right? Infinitely. All right, so that's it. This is our set, right? Starting with 4, multiples of 4, and it goes up to infinity, right? We can get an infinite number of multiples of 4. Now, let me just highlight. This is a finite set, right? Because we have a limited number of elements, 1, 2, 3, 4. However, this would be an infinite set, right? Infinite set. Okay? Good. Now, these symbols, you need to memorize them if you haven't. So this E right here represents this sentence is an element of. So A, lowercase a, is an element of uppercase A, but we don't say that. We just say A is an element of A. Now in this case, we use the same letter, right? But this one is lowercase. This one is uppercase. So they're different. Same letter, but they're different. So they represent different things. This is an element. This is a set. If you draw a line across the E, it means it's not an element of the set. This N represents the number of elements in set A. Okay, this right here. Can I spotlight? Oh, perfect. Let me see. Oh, but that's on. Okay, never mind. That's on the whiteboard. Okay, so yeah, this N, and the A inside the parentheses means the number of elements in set A. And this is the symbol for the empty set, okay? Or the null set. For example, a set which has no elements. All right, so let's see. Example 3, we have this set right here, set A, with these elements, 1, 2, 3, 4, 5, 9. How many elements does it have? And we have to say whether or not this statement is true. 7 is not part of set A. So let me just open my whiteboard. So example 3. So that's our set A, and well, let me write it real quick. 1, 2, 3, 4, 5, 9. 1, 2, 3, 4, 5, 9. So how many elements? 1, 2, 3, 4, 5, 6. So this equals 6, right? And now this statement here, 7 is not an element of set A. Is it true? Yes, right? This is true because 7 is not in this set. All right? Okay, moving on. Example 4, write out the elements of the set S if the elements of this set are even integers and they are between 2 and 10. Okay? So example, so we have S, have Y such that, where is it? Y is an even integer. I'm going to use this for integer, okay? Even integer. And is going to be between 2 and 10. So let's just list the elements. All right. So we have obviously 2, right? 2 is even, 4 is even, 6 is even, 8 is even, 10 is even, but 10 is not included. So that's it. That's all our set. 1, 2, 3, 4 elements in this set. Okay. All right. Now subsets. Let's take a look at subsets. We need some notation for subsets. All right. Let's see. If each element of set A is also an element of set B, then we say set A is a subset of set B. Okay. And this is the notation we use. This sideways U. A is a subset of B. A is not a subset of B. And you can find all the number of subsets with this 2 to the n. So you count how many elements there are in the set, and you use that as your index, and then you raise number 2 to that index. So to show you an example real quick, if I have a set K, and I have just A and B. So to find out, we got 2 elements, right? How many subsets can I get? Well, you do 2 to the n, and that's going to be 4 subsets. And what are the subsets? Well, let's see. You're going to get A, B, A, B, right? And lastly, the empty set. Okay? These are curly brackets. Let me just do a better. I'm doing it quick, but these are curly brackets. And when you do sets, you want to use curly brackets, okay? These are curly brackets. These are parentheses. Brackets. These are parentheses. Curly brackets, brackets, parentheses, okay? So for sets, you want to use these curly brackets for sets, okay? To separate algebraic expressions, you want to use these 2 here. Brackets and parentheses. Okay. So let's take a look at an example. Oh, we have to make note this. No, what are you doing? From the definition of a subset, it is true that 2 of the subsets of a set are the set itself and the empty set, okay? So if you look at my example here, this right here is the same set. Use a different color just to mix it up. Same set, right? AB, and the empty set. So those two are always going to be part of your the list of subsets, okay? So that is for any set. The same set is a subset of the set, right? A is a subset of A, and the empty set is a subset of A, all right? List all the subsets of the set 1, 2, 3. So let's see. Oh, come on. I'm tired because it's late. It's late. So let's see. It is 10:08 right now. I will go to sleep soon. So we got 3 elements. So n equals to 3. So that means 2 to the third power equals 2 times 2 times 2 equals to 8. So we should have 8 subsets. So let's list them out. Subset 1, subset 2, subset 3, 1, 2, 2, 3, 1, 3. So we got 8. How many? 1, 2, 3, 4, 5, 6. And then we have the same set, right? 1, 2, 3, and the empty set. And that's it, right? These are all the subsets of this set right here. Okay. All right, example 6, we have these 3 sets, and we have to state true or false for each statement. Now, let me try to see if I can do this on this PDF, because it'll be easier. This right here, can I write? Let's see. State true or false for each statement. In the set A, in the set C. Sorry. So we have these 4 elements. Are they in set C? -3 is there. -1 is there. 3 is not here, right? 1 is there, but 3 is not. 3 is in A. 3 is not in C. Therefore, this will be false, right? A is not a subset of C. False. False. All right. The empty set is a subset of C. This is true, right? That's true for any set. And B is not a subset of A. That's false because this will be false. All right. Moving on. The union and the intersection. So the union of sets A and B is a set formed by combining the elements of A and B into one set. Any objects which are the elements of set A or B, or both, are elements of union A union B. The intersection of these 2 sets is a set of objects which are in both sets A and B. And this is the notation we use for this. This is for the union, this is for the intersection. Like I said before, the element would be in A or B, and if it's an intersection, the element would be in A and B. These joint sets or mutually exclusive sets have no elements in common. Okay? Their intersection is the empty set. Okay, example 7, we have these 2 sets. We have to write the union and the intersection. So, let's see. You want to add them all up, but you want to count the intersection, the repeated elements only once. So we have these 2 elements here, 9. You don't want to say you don't want to count 9 twice. So how do we do that? Let's see. Okay, so we have set A with 1, 3, 5, 7, 9, and set B with 2, 4, 6, 9. And the union would be, right? Union A, union B would be 1, 2, 3, 4, 5. Is there 6? Yes, 6, 7, 8. No, 8 and 9. 9 is repeated, so we only do it once. And the intersection of A and B would be 9. Okay? All right.